Hi. Unfortunately, I can't make it to class today, but I still wanted to get this next lesson in with you guys because it's got some important stuff. I want to keep us on track. So we're starting a new unit, but the good news is we're using a lot of stuff from the last unit. So we're going to start out with this task. Now, you'll notice I have a bunch of black splotches. You'll see what those mean in a moment, but we're going to start with our problem. For this problem, we're going to pretend we have a sister named Savannah who's 3. She wants to fill a piggy bank. She starts out with 5 pennies, and each day we come home from school, she's excited because we're going to give her 3 pennies that's left over from our lunch money. So we're going to use a table, a graph, and an equation, create a mathematical model for a number of pennies in the piggy bank on day n. Now, over here, you'll see that I already made a table. I'll show you where I got all this information. Now, before we've given her any money, on day 0, Savannah's got 5 cents. Then, after day 1, she gets up to 8 cents because we have added 3 cents. Each day we are... Oh, yikes. Gotta be careful of that stuff. Alright, let's try that again. And much better. So we went up 3 cents. You notice I represented this in dollars. And each day, same thing's happening. We're going up 3 cents. Which means Savannah's getting 3 cents every day. So, the first vocabulary term we are going to be covering today is domain. Maybe you've heard this before in a previous math class. What domain represents are the inputs of a function. So in this case, the input would be our days here. So if we wanted to even represent this, basically days are going to be greater than 0 because you can't have negative days. So if you're asked to represent, what's the domain of this function, you could say that n would be greater or equal to 0. Because you can have 0 days, but you can't have negative days. So we could keep giving Savannah pennies forever. Hopefully we're not in school forever, but if we, every day we went to school, we got our 3 cents back, we kept giving her 3 cents a day, then you could have, everything above 0 essentially. Now the next term we're going to be learning is range. If domain is your input, then guess what? The range is going to be the outputs of a function. So, you may be asked at some point to say, what could the range be for a function? In this particular function, let's see. On day 0, we start out with $0.05 or 5 cents, right? And our values can keep going up. Savannah can keep getting pennies from us. This could go on for a long time. Unfortunately, say we're stuck in school for the rest of our lives, and we just keep giving Savannah 3 cents. Then she'd get 3 cents every day. So the output could be anything above 5 cents. So you notice I'm using inequalities here. If you're not familiar with that, we're going to be using those in the future. But all I'm representing here is that my output can be greater than or equal to 5 cents. Can't be less, because we're not taking any money out of Savannah's piggy bank, and she's not going to have negative cents. So again, domain is all the inputs of a function, range is the outputs of a function. Pretty straightforward, hopefully. And you're going to be using this vocabulary quite a bit. Now, next they asked us to create a table. So I did a table. They asked us to represent a graph. I'm going to hold off on the equation. I'm going to leave that up to you guys. But the graph is going to show us something pretty important here. I already made it. Notice I start with my initial value at 5 cents right here. And then I made ordered pairs to represent all my other points here. So on day 1, right, she's going to have 8 cents. On day 2, she's going to have 11 cents. On day 3, she's going to have 14 cents. And it keeps going up. Now, since this is a arithmetic sequence, we know it's going to be linear, so you might be tempted to draw a line. But hold off, because we got to look at something pretty important here. It says each day when we come home from school, we give her 3 cents. That only happens once a day. We're not coming back a 16th of the way through the day to give her a fraction of a penny. It's only happening once, and she's getting 3 cents at a time. If I were to draw a line here, right? Say I did that. What that would imply is that, say I went like right here, a sixth of the way through the day or something like that. That would mean, that would mean Savannah's getting half of a penny. Half of pennies don't exist. We're not cutting pennies up here. So we can't give her half a penny, and also we can't come back from school a sixth of the way through the day. You know, we could get in trouble for that, and would it be worth it to give your sister a fraction of a penny? No, because they don't give you fractions of pennies, and you don't have fractions at school. This isn't happening. It's only happening once a day. She's getting 3 cents. What this would be is our next vocabulary term, a discrete function. That means that your domain and or range is limited to a specific set of values. So in this case, we are limited to pennies. We are limited to days. We can't have fractions of a day based on this function. Again, we're not coming home a third of the way through the day to give her, maybe a cent. Or we can't come home a sixth of the way through a day, give her half a penny. These events are only happening once, so I can't represent this with a line. All I can do is represent a dot for each day. Now, this could go on. I could put in another line here, right? For day 5, when she would get 20 cents. But again, as I said, there's no fractions happening here. She's not getting fractions of a penny. I'm not coming home like a sixth of the way through the day to give her money. I'm not getting in trouble for that, right? I won't get in trouble for leaving school. So, this is what would be called a discrete function, limited to specific sets of values. Now, we're going to take a look at another type of function down below. Now, we have a small pool for relaxing. It's got 1,500 gallons. We decide we want to fill it. Now, when we had 5 gallons of water in the pool, we decided we didn't want to stand down and watch it fill anymore. So we got to figure out how long it's going to take so we can just leave it. We don't want to sit there and watch it. We just want to leave the hose in there and let it fill up. So we check and we see that it's filling at a rate of 2 gallons every minute. So it's asking us to use a table, graph, and an equation. I'm going to give you a table, I'm going to give you a graph, but the equation, that's going to be on you guys. Alright, so again, I'm going to make a table. So I've got t minutes and then f of t. You know me, I'm not a big fan of t, but following the directions here. So my domain here is going to be my input, which in this case is time, or minutes. My range here is going to be gallons. My output, this will be my range. Now, before I've even left, it starts out with 5 gallons. And then it's telling me it's filling at a rate of 2 gallons every minute. So after 1 minute, we've got 7 gallons. After 2 minutes, I've got 9. After 3 minutes, I've got 11. So I'm going to make a pretty basic graph here. And here's going to be the difference now. Now down below here, I'm going to have my domain, which is going to be minutes. So it's going to be 1 minute, 2 minute, 3 minutes, and so on. And now my range up here is going to be gallons. So I'll put G here to represent gallons. And domain here, I'm going to put minutes. Alright? So, let's see. This goes up to about 11. So I'll make this 12. Just break it up into pieces. 6, 3, 9, and so on. So, at 0 minutes, I've got about 5 gallons in there. So I'll represent that. Again, I'll label it 0, 5. At 1, I've got about 7. 1, 7. At 2, I've got about 9. 2, 9. And 3, I've got about 11. Notice I'm just labeling. Now, here's the thing. You can have fractions of a minute in this case, and guess what? The hose doesn't stop. If I wanted to figure out how much was in it half a minute, I'd be up to 6 gallons. If I wanted to figure out what was up at 1.5 minutes, I'd be at 8, because again, it's going up 2 every minute. So that means it's going up 1 every half minute. I can go out there and measure the gallons literally any second, and I could get fractions. And the time can be broken up. It's continuous, which brings us to our next definition here, a continuous function. Which means essentially that your domain and range are essentially infinite, or can be any values. They're continuous. Now, I know it can't be negative, but if we were asked here to represent what it could be, it could literally be anything. Because guess what? I can come in at a fraction of a minute, and guess what? There can be fractions of a gallon in there. The hose isn't just spitting out water every minute. It's not just going to go blah a minute and then stop. And then another minute goes by, blah, spits out water and then stops. It's going to keep going. It's a continuous function. So they can literally be any values. It's not limited. And that's a continuous function here. So the big things you want to pull from today are domain, which are the inputs of your function, range, which are the outputs, and discrete functions, where it's limited to a specific set of values. And continuous, it can literally be anything. Now we can even break it down a little bit. You'll notice here that I start breaking down whether these were going to be discrete or continuous for 3 and 4. When I took a look at 3, it tells me I have a bank account that pays 3% interest, and here's the key, at the end of each month. It's only happening at the end of each month. So it tells you start with $50, and then it's asking you to use a table and a graph to create a mathematical model for how much you're going to have in your account. Now here's the thing, it only happens at the end of each month. You gotta leave your money in there, because say, I couldn't go back like a day into the month and say, hey, did I gain any money yet? No, you didn't. You're only getting the money at the end of the month. So it's only happening at specific intervals. This would be discrete, because you can't go in for fractions of days and see any change. So you'd end up with a graph that would look something like this. Like your months would be your domain, your dollars would be your range, right? You're going to end up with dots again. Because guess what? There's nothing happening in between these months. Everything's happening at the end of the month. Whereas for our next one here, we're draining a swimming pool. We drain it and there's more water in the pool. So I wanted to figure out the range, and I found out it was draining at 3% every minute. Again, this hose, it's going constantly. It's not stopping. This would be a continuous function. Because again, it's not like it's going to spit out water at the end of every minute and then stop. Spit it out and then stop. It's going to keep going, which makes it a continuous function. So these are the big things to pull from today. Discrete functions, continuous functions, as well as the domain and range. Best of luck with the rest of this task. Good luck, and we'll go over and review it. And if you have any questions, you know you can always reach out to me.